Hello Physical Science, this is Mr. B, and we are starting the last chapter, or I'm sorry, the last section in Chapter 5. It's Section 3, and it's titled Representative Groups. And what this section is going to focus on is the different groups, because remember what a group is in the periodic table, that are represented on our periodic table, why the different groups are located where they are, and why the groups are actually going to be maybe a little bit even almost a better classification based off of properties. We're going to go see more similarities going up and down than we are to left to right. So we're going to break this up. I think we're going to be over 3 parts with this video. So we're going to be kind of take it easy to make sure we get familiar with each one of these groups and kind of some of their properties and characteristics. So to start, we always start with an example and are kind of a real-life comparison, and it poses the question, why is hydrogen located on the left side of the periodic table with active metals, even though it is a gas? So remember when we colored our periodic table, hydrogen is over on the top left, is probably the only one over there on that side that is a gas at room temperature, and the other ones are all metals, and hydrogen is a non-metal, so why is it in that location? So its location is related to its electron configuration. That's a big thing. Hydrogen's located based off its electron configuration, not its properties. Hydrogen can be used as a fuel in automobiles because it is flammable. That's just one of the properties that it gives. Again, and that's a property that's really not similar to any ones that it's kind of lined up with. But the reason why hydrogen is where it is based off of electron configuration, and that's going to be a big overriding theme for the rest of this section. And again, electron configuration, all that means is kind of where the electrons are located, how many there are in certain areas, and things like that. So electron configuration is a big deal when we're talking about the different groups of the periodic table. And so why do the elements in a group usually have similar properties? Again, hydrogen kind of being the example, or the exemption here. And elements in a group have similar properties because they have the same number of valence electrons. So that's how you say this word right here, valence electrons. So I definitely make sure I wrote this down. And it is an electron that is in the highest occupied energy level of an atom. So remember, we ended chapter 4. I know that might seem like forever ago, but we talked about how electrons can exist in different energy levels for each atom. And so a valence electron is an electron that is in the highest occupied energy level of an atom. So it is the outermost energy level, and so that is how our groups are going to be classified. They're going to have the same number of electrons in the highest occupied energy level, and that'll make more sense once we actually get into an example of a couple here. So when the A groups in the periodic table are numbered from 1 through 8, the group number matches the number of valence electrons in the electron configuration of an element in that group. So what this means is, again, I know it's a mouthful there. So group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 3, 3 valence electrons, and so on and so on. And just because and this is where I remember I always got a little bit confused about this. And it doesn't mean that they're necessarily in the same energy level. So remember we have like 4 different energy levels, or something I can't remember exactly going back. And again, it's been a long time for me too. So one element might have its valence electrons in the 2nd energy level, and so on up into the 3rd, into the 4th, and so on, going up through there. So groups, again, 1 has 1 valence electron. And the reason why valence electrons are important, why they even matter, is because they play a key role in chemical reactions. So based off of how many electrons you have available in your outer shell, that's going to play a role in what kind of elements you can bond with, what types of things you can react with, and that's kind of what we're going to see in our next chapter. So these are going to keep constantly building onto one another. And then properties will vary across a period. So remember, period is our rows, because the number of valence electrons increases from left to right. So towards the end of one of our last videos, we looked at how different elements are, again, in their properties and their reactivity going from left to right, and that is because they have a different number of valence electrons. So all of this is really important, and I know it can be a little bit confusing, but we will go back over it again. So make sure you write down anything you're confused about with these valence electrons, because like I said, it might take us a couple tries to really fully grasp these. So elements in a group have similar properties because they have the same number of valence electrons, which we already said. The properties are not identical because the valence electrons are in different energy levels. So that's what I kind of mentioned earlier, that again, hydrogen, again, we'll give an example and that'll help it make more sense. So because hydrogen has a single valence electron, it is grouped with other elements such as lithium that only have one valence electron. So hydrogen has only one electron to begin with, so obviously its outermost energy level is its only energy level. So lithium, it's going to have maybe its first energy level will be completely filled up, and then its second energy level, it's only going to have one electron floating out there. And then if we keep moving down, we're going to kind of see a similar pattern there. So they're not identical because it's not like hydrogen and lithium have that valence electron located in the exact same place. Hydrogen is more close probably to the ground state with its one electron, whereas lithium might be a little more, again, it might be floating out there in an energy level a little bit farther away. So it's going to have a similar but not identical property to hydrogen. And again, I'll explain that more in class, hopefully to clarify that, but that's about as best as I can explain it right now. And so to wrap this up, this video, we're just going to talk about the properties of the A groups in the periodic table, and we're just going to start actually with the first one, the group 1A, and it's called the alkali metals. So this is our first group, again, group 1A starting on the left. So hopefully you remember when you numbered it, we numbered it 1A going and then 2 going from left to right. And so these metals have a single valence electron and they are extremely reactive. So this is a really interesting thing about this group, is how reactive they actually are, and we're going to watch an interesting video in class tomorrow that kind of shows us how reactive these elements actually are. And because they are so reactive, they are found in nature only in compounds. So they are so combustible, they're so reactive that if you leave them by them, that they cannot be found. They cannot be found by themselves in nature. If they ever existed on their own in nature, they basically just explode. And we're going to see that again tomorrow, which I think is really interesting. And the reactivity will increase from the top to the bottom. So the top is the least reactive alkali metal, and when we get down to the bottom, we'll see a list here. Like lithium, okay, we'll jump ahead. Lithium is our least reactive of the alkali metals, and francium is our most reactive alkali metal, which we'll take a look at hopefully actually in class on Tuesday. And so, just to give some examples, sodium reacts violently with water and it releases enough energy to ignite the hydrogen gas that is produced. So when you mix sodium with water, hydrogen gas is produced, and then so much energy is released that that hydrogen gas actually catches on fire, which is really interesting. And sodium and potassium are stored under oil to keep them from reacting with oxygen and water vapor in air. So they're so reactive we can't even just store them in a normal container. If we store them in a normal container, they're going to react. So they're actually stored in oil. And then cesium, it's so reactive that it's usually stored in a sealed glass tube containing argon gas. So these are so reactive that we usually don't have the ability to work with them in a normal classroom, probably a little bit too dangerous for our liking. So, and that's why we're going to watch a video in class tomorrow. And we'll see a little picture here. It says, unlike most metals, the alkali metal sodium is soft enough to cut with a knife. And this is kind of an example of what sodium looks like when it reacts with water. Enough energy is actually released to ignite the hydrogen that is produced. So this is just, again, a little tidbit of what you're going to see tomorrow. So this is our first group 1A, all the way on the left, the alkali metals. So they're very reactive. We're going to take a look at them in class tomorrow. So that's it for this video. Let me know if you have any questions.